Welcome to this explainer. Today, we're diving straight into the underlying architecture of the modern web. Now, I want you to approach this session just like we'd examine the anatomy of a massive modern high-rise building. We interact with these beautiful digital structures every single day, right? But how often do we actually stop to look at the blueprints, the concrete, or the plumbing that makes them work? Well, by the end of our time together, the invisible mechanics of the web are going to be completely demystified for you. Here's our syllabus for today. It maps out the core knowledge you need to fundamentally grasp how the web operates. We're covering the infrastructure of the web, static versus dynamic pages, the core front-end trifecta, the evolution to HTML5, understanding tags and elements, and finally, graphics and browser compatibility. All right, let's jump in. Section 1, the infrastructure of the web. To start our metaphorical journey, we really have to look at the underlying network where our digital buildings are constructed. I mean, without the land and the roads leading to it, a building is pretty much useless. Okay, let's clear something up right away, because a common stumbling block for a lot of undergrads, and honestly, even some seasoned pros, is mixing up the physical network infrastructure with the information system that actually rides on top of it. So think of the internet as simply a network of networks. It's the physical cables, the routers, this vast global highway of connected computers. The World Wide Web, on the other hand, that's the fleet of delivery trucks using those highways to transport and share files and information as web pages. Looking at this setup here, you can see how multiple web servers, which are basically just specialized super high-speed computers, are situated across completely different geographical locations, like Asia, the US, and Europe. They are all seamlessly connected by that underlying internet infrastructure. So when organizations need to share data globally rather than just internally on a local network, they use this massive infrastructure. It essentially creates the absolute largest wide area network, or WAN, in existence. Now, the really crucial part is understanding what happens when you actually try to interact with one of those global servers. Accessing them operates a lot like dining out at a restaurant. Your web browser acts as the customer sitting at the table requesting a meal. The web server, that acts as the kitchen. It holds all the ingredients, the pages, the images, the data, and prepares your request to send back out to your table. And this interaction builds into a highly formalized communication loop. It's a three-step process that is quite literally the bedrock of web communication. Step 1. The user specifies the Uniform Resource Locator, or URL. That's you ordering a specific dish from the menu. Step 2. The client browser sends that request over the internet, so the waiter taking your order to the kitchen. And Step 3. The web server processes that request and sends the formatted web page back as a response. This whole shebang relies entirely on the Hypertext Transfer Protocol, or HTTP, which sets the strict rules for exactly how the kitchen and the dining room talk to each other. Section 2, static versus dynamic pages. Now that we understand how pages are delivered, let's look at exactly what types of pages are being served on that plate. Early on in the web's evolution, technical limitations meant pages were purely static. You can think of a static page just like a printed brochure. The content is set by the designer, and the exact same content is shown to every single user. There's no real interactivity, and updating it means manually editing code line by line, which, as you can imagine, raises the risk of inconsistent info. Dynamic web pages, though, they introduced a massive paradigm shift. They generate content on demand. When a user provides input, the page interacts with a database of organized data to instantly create a highly personalized experience. Think about adding items to a shopping cart and immediately seeing your newly calculated total. That's a dynamic page in action. Moving on to Section 3, the core front-end trifecta. So how exactly do we build these robust dynamic experiences? Let's take a look. If we go back to considering web development as constructing a modern high-rise, these three technologies are your primary building materials. First, you have HTML, or Hypertext Markup Language, which provides your structural foundation. It dictates exactly where the walls and floors go. Next up is CSS, Cascading Style Sheets. This acts as your interior design. It handles the visual aesthetics, specifying fonts, colors, and layout positioning. Finally, we have JavaScript, which powers the complex interactivity. It's the electricity, the plumbing, and those interactive elevators that respond to user actions and actually make the building livable and dynamic. Section 4, Evolution to HTML5. Let's focus our attention on our foundational concrete for a moment. It's super important to remember that HTML isn't some ancient, static text. It's a constantly evolving standard. Tracing this history reveals a pretty fascinating narrative. HTML was formally introduced in 1990, and it evolved quickly.
A major milestone hit in January 1997 with HTML 3.2, which was the first standardized specification by the W3C, the World Wide Web Consortium. Later that same year, HTML 4.0 brought critical support for CSS and JavaScript into the mix. But the real revolution kicked off in 2006, when the W3C partnered with the WHOTG group to start developing HTML5. And this march toward HTML5 was driven by pure necessity. We needed the web to be completely device-independent, to provide native multimedia support without those clunky old plugins, and to replace complex scripting with elegant descriptive markup.
Section 5. Understanding tags and elements. Keeping that evolution in mind, let's zoom in on the actual bricks and mortar used to frame our structure. Now, what's really brilliant about HTML5 is how logical the layout has become. Back in the day, before HTML5, developers had to use generic divisions and tables to visually hack a layout together. But HTML5 introduced highly descriptive semantic tags to logically organize a document's body. As you can see in this standard layout, we now have dedicated structural tags, a header for your logo and titles, a navigation bar cleanly separated from everything else. The main information holds top priority right in the center, flanked by an aside or sidebar, and finally a footer at the bottom for general site info. It makes the code instantly readable both for human developers and for machines.
Literally every piece of content you see on the web is housed within these fundamental elements, and they generally fall into two distinct categories. First, you have container elements. These act like boxes, they have an opening tag, the actual content inside, and then a closing tag. Standalone elements, however, consist only of a start tag and its attributes, ending immediately with the /. They don't contain any internal text. Think of an image tag, for example, which simply points to a file rather than wrapping around text. These elements are organized hierarchically to create that basic, rigorous HTML structure of every single page.
So here's a question for you. Let's say we've built our perfect website using HTML5, we've painted it beautifully with CSS, and we've electrified it with JavaScript. But how do we guarantee it looks the exact same on every single device? Well, this leads us directly to the final, and let's be honest, often the most frustrating challenge of our construction project: public exhibition. We've built this magnificent digital high-rise, but how do we ensure that every single visitor experiences it exactly as we intended, regardless of the phone, tablet, or software they're using?
That brings us to our final topic, Section 6, Graphics and Browser Compatibility. Delivering our site to the public safely and efficiently requires incredibly careful management of our graphic asset sizes and a deep understanding of how different software interprets our code.
Let's talk about visuals first. Graphic files are large, and sending them over those internet highways takes time. When loading graphics onto a site, developers have to balance pristine visual quality against file size by choosing the correct compression algorithms. Lossless compression mathematically reduces the file size while preserving an exact copy of the original uncompressed data. This is absolutely vital if you want to avoid visual artifacts when repeatedly editing an image. Lossy compression, however, discards some data to create a mere representation of the original image. It's not an exact copy, but the trade-off is it achieves significantly smaller file sizes, which drastically speeds up page loading times for your users.
But optimizing your images is only half the battle. Your HTML, CSS, and JavaScript must be interpreted by a browser's rendering engine. And here's the catch. Different browsers use entirely different engines. You've got Gecko powering Firefox, Trident used in older versions of Internet Explorer, WebKit serving as the powerhouse behind Apple Safari and many Android platforms, and Presto, traditionally used by Opera. Because these engines interpret code in slightly distinct ways, a website might look absolutely perfect in WebKit but completely break in Trident. Because of this, writing clean, universally valid HTML and rigorously testing your structure across these multiple engines is absolutely mandatory to ensure optimal browser compatibility.
We've covered the foundation, the structure, and the finishing touches of the modern web. But honestly, understanding this core architecture is truly just the beginning of your journey. With HTML5 constantly pushing boundaries by introducing native APIs for robust mobile applications, geolocation, and even true offline capabilities, the blueprint of the web is continually being redrawn. As future developers and technologists, we have to ask ourselves, as HTML5 continues to evolve, what entirely new architectural paradigms will the web buildings of tomorrow require? I encourage you to keep exploring, keep building, and thank you so much for joining me in this explainer today.